Dear participants, due to a small technical glitch, this was delayed, but we will connect with the resource person in just a few moments, and we will begin with the session. Just I appreciate your patience. We will begin shortly. Sure. Good afternoon, dear participants. I welcome you all to this fifth day of this online internship program on industrial progression of mechanical engineering, organized by Mechanical Engineering Department of St. John College of Engineering and Management, Palghar. So, for today's session, we have resource person Mr. Aldrich D'Souza, and his topic of presentation is implementation perspectives of sustainability in industrial business process environment. So before beginning with the session, let me just introduce you with today's resource person, Mr. Aldrich D'Souza. Mr. Aldrich has completed his Bachelor's of Engineering from Mumbai University, as well as he has completed his Master of Science in Sustainable Engineering Systems from Rochester Institute of Technology, USA. Presently, he is functioning as the director of Britannia Offset Private Limited, Mumbai, and more importantly, he is involved with various sustainability related projects so that he can help the environment. One of the prominent benchmark projects has been the feasibility analysis of implementation of black soldier flies food composter at Rochester Institute of Technology in December 18. This project particularly investigated the effect of using black soldier flies to digest the food waste, which is a common practice at various scales throughout the world. In the long term, the RIT was focused on designing a continuous BSF composting system. Such a system is supposed to be able to digest organic food waste produced by campus dining facilities at various institutions with minimal power consumption so that optimal shade conditions can be maintained for the purpose of optimal performance of BSFs. BSF is nothing but black soldier flies. So, particularly, this project was related with feasibility study of the composting process in a self-sustaining shed, and it was located in the western region of New York. So, I welcome Alrit sir to this session, and I request him to take the control of the session. But before that, let me just inform the audience that this will be more like a discussion kind of session rather than just a presentation, because we received some feedbacks from the participants that it should be more interactive, that a resource person is presenting their PPT, and there is a lesser inputs from the participants. So we have created some questions, and we want to short them towards Alrit sir, considering his expertise in the sustainability systems. So we are going to fire those questions, and sir is going to answer them. So, sir, shall we begin whenever you're ready?
Hi Hitesh, we're good to go. I'm ready.
Okay. So, sir, the first question for today's session is, what exactly is the meaning of sustainability, and why should everyone, even if a technocrat as a citizen, should be concerned about it, should care about it?
So, as all of us have been hearing, first of all, good afternoon to everyone who's involved, all the participants from variety of disciplines. We've got students from our own institutes, we've got students from other institutes in Maharashtra, we've got students from Pan India, we've got industrial participants, we've got professors who have joined in as well. Warm welcome to all of you all for this 7-day workshop. Today is day 5, I am told, and I've been given the responsibility of conducting a session on sustainable implementation perspectives in industry. Um, I may not be the foremost expert in this field, but I gained a lot of experience in this relevant field, and I noticed there is a great lacuna in implementing sustainable practices in our own country. This was one of the very reasons that brought me back from the US to India to see what I could do better over here. So, going forward to question number 1 from Dr. Hitesh, what is sustainability and why should you care about it? All of you might have heard of multiple issues like climate change, we've got pollution, we've got resources running out of their reserves, we've got wars, battles being fought over resources. We are seeing that there's a lot of wastage in our day to day lives in a variety of sectors. And we're also hearing that living is becoming more expensive. There is a rising cost of living. So, if you think that these issues are really concerning, then you've definitely reached the right place to talk about sustainability. If our current generation does nothing to live in harmony with nature or to re establish a certain equilibrium with nature, there will be nothing left for the future generation. According to most scientist projections, by the year 2100, Earth will be a barren wasteland if our current rate of emissions and temperature change continues. So, sustainability is the process and the practice of living in equilibrium with the nature, with the surroundings, and trying to adapt our practices to mimic natural practices to ensure that this harmony is maintained.
Okay, sir. So now that we have established the context about sustainability and its necessity, but then that's about sustainability, how to incorporate that as a sustainable engineering.
All right, so we went through what is sustainability, and now we go forward to what is sustainable engineering. So, as I mentioned previously, sustainable engineering is the process of designing or operating systems such that they use energy and resources sustainably. Now, sustainable is a very broad term that is constantly used. What would you mean by sustainable? It is a rate at which where we do not compromise with natural environment or the ability of our own future generations to go forward and meet their own needs in the future. And sustainable engineering is very closely related to mechanical, industrial, civil, and production engineering fields. Some of you may also know sustainable engineering as environmental engineering as it is offered in a few Indian universities and colleges.
Okay. Uh, so, sir, which are different fields which come under the umbrella of this sustainable engineering?
Um, So sustainable engineering is not only okay, I wake up and I say, today I will not use a particular product, I will do X instead. For example, today I will not use my vehicle to travel, I will walk to the place of work instead. Now, if your workplace is 1 kilometer from your house, 2 kilometers from your house, you can walk. But if your workplace is 40 to 50 kilometers from your house, I don't see people wanting to walk to their workplace every day. And I don't think it would be possible that they would reach on time and they would be able to contribute suitably to work in that condition. So, sustainable engineering is broken out into multiple wider branches. We begin with the fundamentals of sustainable engineering that lay down the principles by which sustainable engineering relies on, follows on. The second thing is designing for the environment, where you go ahead and you study the principles of designing products or processes so that you can mimic these similar processes in nature, leaving a very small ecological footprint after the whole process is complete. Thirdly is life cycle analysis, and number four, product life cycle management, very closely related to each other. Life cycle analysis and product life cycle management is a huge topic by itself. In life cycle analysis, we look at a product right from the design stage up to the end of life, that is the end of use phase, and what happens through these phases. Where is the user involved? Where is energy involved? where is waste being created. The same also goes for product lifecycle management, where the management phrase in this term is implying how do we make the most out of each stage of the product life? How do we make the designing cost effective? How do we make the production efficient? How do we make the usability open to a lot more of users? How do we make sure that it is easy to recycle at the end? This comes in product lifecycle management. Following that, there is design for manufacturing and assembly, which post a product gets designed. Okay, a lot of you have seen automobile shows where they keep showing you concept cars. And most of you all will realize that concept cars really look way out of this world. They look very futuristic. They look high tech. They look very classy. But when the manufacturer has to produce the car, he realizes that certain of these design features will not be possible for large scale production. The concept car may have 20-inch tires, but 20-inch tires may cost 20,000 rupees per tire. And the target audience will only be able to pay 4,000 to 5,000 rupees per tire. So over there, there is a compromise sought. So design for manufacturing and assembly is nothing, but it bridges the gap between the design concept towards the production phase of the product or the process, which makes sure it's cost effective and energy effective to do so. There is engineering of systems, which goes into designing of processes, designing of systems in order to optimize their output, in order to optimize the product quality, in order to correctly allocate your resources towards a certain process according to the importance or the priority of the process. Renewable energy systems, a lot of you are familiar with it. It is an elective for some of you all. Renewable energy systems goes through the various energy sources that are available. It weighs the pros and cons of them, and it could have a project related to implementation of a renewable energy system in place of a conventional energy system. Solid waste management, air emissions, and wastewater treatment. Once again, dealing with pollution. How do we deal with the effluents? How do we treat the effluents? What is a balance to be achieved between how much waste should be treated and how much energy and cost goes into treating such waste? And what is acceptable as per the limits set by the government or the pollution control boards? Energy policy is a new topic, not very well heard of in India because energy policy does not technically exist clearly in India. But energy policy defines whether X amount of energy should be subsidized, should be produced from conventional sources, should be produced from renewable sources, what should be the distribution, what should be the tariff, so on and so forth. And finally, supply chain management, which is another one of my favorite fields in the sustainable engineering. An optimized supply chain can save you 30% cost per year. And this 30% cost is split over warehouse space, transportation, energy, wastage, manpower required to handle the excess supply chain, along with excess product losses due to excess production of such a item. So these are the major fields that come in under sustainable engineering, and there are multiple subfields where you can go forward and do your specialization in case you have an interest in those.
Okay. So now these fields have been underlined, but particularly this product life cycle management is crucial even in mechanical engineering or any other stream of engineering. So we will like to have some more elaboration upon it, more focus on the topic.
Okay, so going forward for product lifecycle management, I have another PDF which I would like to share with you. If you give me a moment to just stop sharing. Okay, so right now you can see there's I've got a nice little PDF for product life stages and product life cycle. And the question always goes as to what do you mean by product life cycle? We have not heard of it. And it's not even taught in basic engineering, which I feel product life cycle should be a final year subject added in. So going forward, we look at the traditional product life cycle. All products start with a design, and the design comes from the question, why do we need this product? Can this product make some part of our life better? Can it add value to our life? Can it add value to a process? Can it make things easier? So, a lot of questions are asked before a product is designed. Going forward with a vehicle as an example, before any vehicle is designed, the most important questions that are asked: who are we aiming this vehicle towards? How many people should be fitting in this vehicle? What should be the fuel efficiency target? What should be the cost of this vehicle? And all these questions influence the design phase of a product. So once the design is fixed, and the design can be fixed using expertise of internal teams, using questionnaires that are passed out to focus groups. For example, if I'm designing a seven-seater vehicle, my focus group will be joint families in India, because I know that there are always more than five people traveling with their luggage in a seven-seater vehicle. So, identifying a focus group, identifying your target audience, identifying your internal experts all plays a very important role for the design phase of a product lifecycle. Once the design is firmed up, we move towards concept creation, where we talk about raw material acquisition, where the first question is, how are we impacting the earth and its ecosystem? Raw materials for any vehicle can only be produced from planet Earth. It's not like we're going into outer space to get the stuff. So the question arises, how are we impacting the earth and its ecosystem when we take out the raw material? Forwarding from that, we go towards material processing. Somebody may question me, what do you mean by material processing? I would love to give you all the example of aluminium. Aluminium is a very strong, light metal that is used in a lot of vehicle construction nowadays. Most of the aluminium reserves on the earth are located in the country of Australia. And transporting the aluminium bauxite ore from Australia to the place where it is going to be converted into the metal aluminium covers almost 30% of the energy required for material processing. So, my question over here is, how do I make sure that the material processing involves the least amount of energy, least amount of transport, and gives me the most amount of output per unit material extracted from the earth? Going forward to manufacture and assembly, how do I decide my manufacturing plant? What should be my capacity of the plant? How many shifts do I run in a day? How many vehicles am I putting out per day? So on and so forth. Moving on to use and service, every person buying a particular vehicle will not use the vehicle in the same way. Somebody may use the vehicle maybe only for 5 kilometers per day. Somebody may use the same vehicle to cover 200 kilometers per day. How do I decide what is the standard average usage for my vehicle? How do I decide what is the standard interval between servicing of my vehicle? And how do I make sure that the cost of this is affordable no matter whatever your usage policy is? Once the vehicle is done with its service life period, for example, it's designed for 7 years of usage, it goes into the retirement phase, where in case if it is to be disposed, if it is to be scrapped, or in case it is another kind of product which is consumable, how do I treat it? How do I get the emissions out of it? Now, all of this comprises a traditional product life cycle. Today, we all are staring at something called an expanded product life cycle. The expanded product life cycle has a few more aspects to it. As we all can see, design is still here, earth and ecosystem is still here. Raw material acquisition moves on to material processing, moves on to manufacture and assembly, moves on to service and then retirement. Now, what we have realized is as manufacturing processes have gotten better, a lot of components tend to be overbuilt. The phrase overbuilt is used when the component can withstand abuse, can withstand usage way beyond its design limits with a bit of good maintenance, with a bit of care taken of it. So, in the retirement phase and expanded product life cycle, we tear down the product and we identify the parts that can be reused, remanufactured, or recycled. For example, if I feel that the engine in my vehicle was still in good condition, I will tear down, I will move it to inventory. I can remanufacture the engine or I can reuse the engine and put the same product into use and service, or remanufactured engine back into a new vehicle body. Or in case I think the engine is junk, I can melt it, convert it into aluminum and move it into the material processing before manufacturing. What happens due to this is we can save 40% of energy by just following the 3 R's of recycling, remanufacturing, and reuse. In the current sense, it means that we have to work lesser to extract expensive ores from the earth. We will use less energy to transport these ores and also to refine them. Now, for product life cycle, there are two other important factors. There is product cost and there is environmental cost for the product. Now, product cost in terms of money, as you can see, it starts at zero when it is at concept stage and it flattens out at around 80% when we hit the design stage. What this means is if we have to make any changes, if we have to make any improvements to the product, it is cheapest to do it during the concept stage. This is why design thinking is important. The later in the product timeline we decide to make a change or an optimization to a product, the cost increases exponentially. Moving on to environmental impacts from the product, it follows the same curve as the product, as in the product cost during the product timeline. The environmental impact does not exist before the product is a concept. And the moment it goes into the design phase, we know it has hit 80% of the total environmental impact. So, my dear fellow listeners, it's very important to understand what we are designing, the purpose of what it's going to serve, and how long it is going to be used. And post that, how do we want to dispose it or where do we want to use it? Certain of the design decisions that are required for a product life cycle, the performance characteristics, okay, what conditions do I expect my product to work in? What do I expect it not to work in? The architecture of my product, is it better for me to design something currently or is it better for me to design something that can be reused in the future? The material should to be used, should I go with aluminum, which requires much more energy and is easily recyclable, or should I go with steel, which is much heavier and will give me an efficiency hit? The fastening method, should I go with easy to remove screws that are Phillips screws that are regularly available, or should I go with proprietary screws that make sure only my service centers can open it? For the tolerances, the coatings, maintenance, and retirement, these are all heavy design decisions that have to be made before the product is conceptualized. In life cycle management, we look at the retirement options. We obviously have reuse, we have remanufacturing with refurbishment, we have recycling or upcycling, we have treatment and disposal in terms of chemicals and other products, and we have incineration, which is nothing but burning, which is recommended for most of the biohazard products. So, Dr. Thackeray, I hope this was a good answer to the question on product life cycle management.
Okay. So actually, basically, this being an online internship program on the industrial progression, we are more interested in the sustainable development for the industry because industries have their own business processes set up over the passage of time, over the passage of years. But then, if somebody tells them to go for the sustainable development, so does it cost them? Is it a costly matter for the industry, or does it require heavy investments? Because industries are very much reluctant for such heavy investments, particularly when it comes to sustainable development. So, does it require heavy investments?
So, another brilliant question that you have put forth is sustainable development a costly affair for the industries and does it require heavy investments? So, let's look at it from four aspects. The first aspect is manpower. Sustainable development requires a skilled workforce. That is, if I had to do a sustainable development of a manufacturing company, I would require an engineer who could analyze all my processes, my company design, my company layout using a suitable software, be it SEMA Pro, be it Eco Design, and be able to interpret the results to me in terms of a particular unit. If I had to tell you that we could reduce electricity consumption in our company by 30% by switching over to LED lights, it's something that I have interpreted from the report. It's not something that the report directly tells me that, oh, please use LED lights instead of LCD lights. So what would happen in the software is I would put a comparison for energy usage where I would put LCD lights and I would put LED lights. I would have to understand the wattage of both these lights. I would have to understand the brilliance intensity provided by both these lights. Once I understand these concepts is when I can remove a result and tell you, oh, by using lights that are 50% less power consuming, it will be possible to reduce the energy consumption in the company. The second factor is money. It depends on the level at which one is trying to implement. If someone is saying, I want to go completely off the grid, that is, I will not take power from the regular industrial supply or from the regular power company, and I would want to use a complete wind turbine and solar energy solution by setting up it in my own premises. The person has to have the money to back up. The person needs to have the expertise of knowing where to install, how much power will be generated, and where will I use the excess power in case it is supplied to me. Factor number three is updates in technology. So, a lot of processes in our industry are not automated. And if you want to bring in sustainability into your industry when it comes to manufacturing, there has to be a complete integration of process controls so that we know what process is happening where at which particular point of time. Another key factor that is involved with this is lean manufacturing. It is practiced by a lot of the Japanese companies where they have the 5S, they have just-in-time manufacturing, and they have the Kanban system of manufacturing as well. As also seen in the product lifecycle management chart, for updated technology, we will have to have capacity for refurbishment and remanufacturing of our older products to make sure that they are reusable at a lower cost by our target audience. And finally, point number 4 is new design protocols and procedures. If you sit to design your product and process from scratch involving sustainable practices, there will be a delay. And this delay comes in from designing it in an eco friendly manner. Second point being the sourcing of materials could become very tough. I don't know if you're aware of this fact, but a lot of people are going crazy over electric vehicles. Most people are unaware that the cobalt needed in the batteries of electric vehicles comes from the Democratic Republic of Congo, which employs children to mine this cobalt by hand. It is the conditions are terrible. There are multiple articles on this online. So sourcing of materials becomes very tough. And saying this, conflict free minerals are almost impossible to find. As some of you all are aware, China has launched a lot of military force in the South China Sea because it wants to protect the territory for its rare earth minerals, rare earth elements. So there's conflict everywhere. Like the tougher it gets to source your materials, the more expensive your product becomes. Also, you will have changes in your post production practices. For example, earlier you could just, before trying to be sustainable, you could you could let out your waste treatment into the nearby drainage, or you could just let out as much of air pollution as you wanted. But now if you want to be sustainable, you want to go by the pollution control board guidelines, you will have to install a waste treatment plant, you will have to have smoke scrubs, smokestacks for your air pollution that will come out from your manufacturing process. So, while it seems to be a costly affair, there are different stages till which you can implement a sustainable approach to your industry. It requires heavy investment if you decide to go for a 100% approach, but if you go for a hybrid model where you take 20 to 25% of your industry is being moved towards sustainable practices, that could be much more affordable.
Okay. Um, so, sir, what happens mostly in an industrial environment? Each and everyone, right from the top management until the bottom worker, everyone is concerned about the production target which is to be achieved. And the methods that you have explained, like this JIT, 5S, the objective is to increase the production volume within the same overheads. And sales targets, production targets, monthly, quarterly, these are main focus of attention, and that is very correct because it is ultimately something that generates revenue for the organization. But then, uh, is there any way by which these sustainability practices or these projects they help the organization to improve upon this production or to improve upon these targets?
So I feel this was a very relevant question that was going to follow this question as well. So in India, majority of production happens in medium and small scale enterprises. And it's mainly unorganized, manual, labor driven, with very low to medium level of technology being used in these companies. Another thing that we've noticed is forward planning is missing in most of these setups. Every order that comes is an express order, every order that comes is an urgent order because these are last minute orders where the client did not plan properly or the company producing it did not produce enough to acknowledge that there would be quality control issues or there would be defective outputs. For example, we run a printing press. When we print for a bunch of, if there's an order of 10,000 copies, we do not print 10,000 copies and call it a day. We print 10,025 copies. These 25 copies are pulled out and they're checked for any blemishes, they check for any errors, they check for wrong color reproduction. Now, if we had to print only 10,000 copies and there were 25 defective pieces, that would mean we would have only 9975 pieces. and I would have to restart my entire machine to just print those 25 further copies. In case I was running the last shift of the day, I would have to pay overtime to my employees for staying back and printing those 25 copies. And this is the result of companies not doing a cost analysis. A lot of companies do not work with a planned schedule. It's just like, okay, the order is come, let's start working with it. We won't plan that, oh, can we do A order on this day and B order for a certain part of the day and C order, so on and so forth. So we have noticed that a planned working schedule may necessitate higher investment in capacity, but this investment will be recouped by avoiding overtime cost. We all know that overtime costs for employees are in the range of 50% of their regular salary as an extra. So if you add up the overtime cost over a period of time, it's going to come out to the equivalent cost of just investing in a newer machine. And adding sustainable practices to this whole mix will improve worker health, definitely will improve worker health, worker happiness, lower cost, it will reduce wastage, and it will also increase the life cycle of products. In sustainable engineering, one of the first things that we're taught is the concept of planned obsolescence. Planned obsolescence came about in the early 1900s. In the US, a lot of companies were fighting to make a light bulb that would last the longest. Suddenly, someone realized if they all sat and made light bulbs that lasted for 10 years, 15 years, 20 years, after a certain point of time, there would be no market left for light bulbs. So, planned obsolescence is where a product is designed to stop working after X number of years or X number of hours or X number of cycles of switching on and off. So, increasing the life cycle length of products will reduce our demands of the environment. It will reduce the energy usage from the environment or the energy required to create a new product as well.
Okay. Now we are mainly concerned about the mechanical engineering industry, and for which skilled manpower works as a major input. But then, what happens particularly for mechanical engineers whenever we tell them to improve upon something, improve upon current business practices, the way they are handling the things, they are very reluctant to change. And what they fear is that implementing some new technology from some new consultant will create workload for them. उनका खुद का काम बढ़ जाएगा. So, does this happen also in case of sustainability projects when they are implemented in the industry?
Sometimes I feel like you're still a mechanical student, Dr. Thakre.
I am for lifetime, of course.
You sound exactly like those students one time.
Yes, and that's human mentality because we see everywhere in industry whenever we propose them some improvement in product or process. So, because the people, when they don't know about the meaning of these things, they are particularly hesitant to accept the change.
So, as you said, everyone keeps thinking, do we have to do we have to do this? Will it be better for us? And everyone looks at short term practices, they look at short term gains, and they forget to see the larger image, they forget to look long and think long. Sustainability practices require a specialized skill set, and critical plus design thinking are the two top requirements for sustainable practices. If if you have been reading the newspapers, there have been multiple reports by all the newspapers saying that the average Indian graduate does not have the basic employability skills in spite of completing their basic degree studies. And the same appears to be true with the mechanical engineers, because what we learn in mechanical engineering and what the industry has moved to is an ever widening gap. Things that used to be produced by hand earlier are now produced on machines on an automated line. Where does a mechanical engineer figure out in this? He should either then be at the design stage, or he should be at the machine operator stage, or he should be at the end product stage for quality analysis and quality control. That is something that mechanical engineers have to adapt to. Now, since these students already lack the employability skills, all the industries who employ these students are reeling under the pressure of having to train these joinees to understand the practices of that company, which means the company trainers are already stretched. This will increase their work. And to get these new joinees, to get the company employees to think in a sustainable manner, will mean that the employees have to think out of the box, and they have to think of their current work plus innovative thinking. This will definitely increase the workload on both the companies, the trainers, and the employees.
Okay. Now, particularly because sustainability it is coins some kind of new technology or new approach towards the entire work culture. So we need someone who can properly schedule, organize, and get programs executed at the industrial level. And for this purpose, we need somebody who is properly trained, properly certified by some government agency. So, is there any particular government certification or training program for particularly for engineering graduates so that they become eligible and industry accepts them with a promise that they will be able to execute the sustainability projects with more probability of success? So, is there any kind of certification available, and what exactly is the minimum experience or qualification requirement for this?
Okay. So I did a bit of research, and as of today, there are only 30 something institutions in India that are offering a combination of BE, BTech, or MTech in environmental engineering. It's not even called sustainable engineering in India, and that's fine, it's environmental engineering. However, environmental engineering is treated as a joke that, oh, are you going to go and study environmental studies in an engineering format? And environmental engineering is also much closer to civil engineering in India than it should be to sustainable engineering. So, my first request is that the attitude of Indian students has to change. This is a field with current potential. I know a lot of the people listening to this may already be students in engineering, but you may always have a sibling, you may always have a cousin who you could advise and say, why don't you go towards environmental engineering? Why don't you go towards sustainable engineering? Why don't you take up topics like that? So the attitude of Indian students has to change, a field with immediate potential, and there is active consultancy in the fields of building design, process design, product design with lifecycle management. What a lot of people do after doing environmental engineering or mechanical engineering with their masters in energy, they all make the mistake of going into renewable energy sources where everyone wants to start up their own solar panel business and their solar energy consultancy, which I feel is a big mistake. Not only are they unaware of the actual market conditions because they come out of college with bookish knowledge, and the market conditions which no one is aware is that China is supplying 90% of the solar PV modules to India, which degrade much faster than the German made modules, and they do not give the advertised output of power, but they're cheap. So there's too many fake experts, there's too many traders masquerading as people who think they know what they're doing in this field. Another thing that students can do is lead certification which is excellent for building design, for energy audit, for energy efficiency design. You can get a LEED green certification, you can get a silver certification, you can get a gold certification, and it is approved. It has a good weightage in India. You can go for the 5S training, you can go for Six Sigma certification. All of these three, they help in changing your thought process. They help you start thinking from an efficiency point of view rather than just an output point of view, and they add weight to your resume or they add weight to your CV.
Okay. Now, actually, we will be more interested to see some live example because this is more towards the productivity improvement. So, are there any live examples of sustainable measures? Because everything looks good in theory, but as an engineer, we are more focused about the outcome-driven implementation. So, are there any examples about it which will indicate technical benefits, tangible benefits, as well as financial benefits?
True. So there are quite a few companies that have gone forward and invested money into sustainable practices, into better product design that will help them save money in the future. And I've got two examples. I've got one example of a company and I've got one example of a country. So Coca-Cola, everyone knows it as one of the largest soft drink brands in the country. Coca-Cola owns the brands of Coke, Thumbs Up, Fanta, Sprite, Coke Zero, Diet Coke, Minute Maid, and Dasani water as well. Now, somebody may think, oh, Coke does this, Coke does that. So, what did they do to improve their efficiency through sustainable measures? The first thing they did is they moved their factory lighting to LEDs with motion sensors. It immediately reduced their consumption by 50% less energy and 50% more light per watt of energy consumed. In the distribution channels for Coke, they installed energy management devices. I don't know if all of you have seen a vending machine, but in case you haven't seen a vending machine, um, so this is what a vending machine looks like. Now, in this vending machine, what Coca Cola did, I know some of you will point out and tell me, oh, look, it's Pepsi over here. But in this vending machine, what Coca Cola did was they installed lights that would only come on when somebody pressed a button on the keypad over here, as well as they optimized the cooling schedule of this vending machine. By doing that, they further reduced. Hold on, sorry for that. Yeah, by doing so, they further reduced their energy consumption by 35%. And ultimately, since they realized that their delivery trucks were all going to short distances from the manufacturing plant, they used hybrid trucks. These hybrid trucks were a combination of electric power along with diesel power. The electric power would help start the truck, would bring the truck to a stop at traffic signals, and this improved its emissions by one third. So, in case a truck was emitting 300 grams per kilometer of road traveled, they dropped down to 200 grams per kilometer of road traveled. Now, Coca Cola also set a lot of goals. They wanted to avoid the use of 1 lakh tons of packaging material. They wanted to recycle or recover 90% of the waste materials, and they wanted to improve the recycled content in their plastic bottles to an average of 10%. Now, while this data that I pulled speaks about 2010, There is data available for 2017 online. What they did towards achieving their goal. The Dasani water PET bottles weight was reduced by 30%, so it saved 493 tons of plastic that would have been produced fresh from petroleum. The plastic caps for these bottles were designed to be 24% lighter, which saved 235 metric tons. And the fiberboard, that is basically the box in which the plastic bottles were placed, was lighter and thinner, saving 124 tons. The company has also launched the plant bottle, which is made of 100% recyclable plastic packaging with 30% plant based waste. What I'm happy to announce is that as of 2017, Coca Cola's plant bottle is made of 100% non virgin plastic. It means that 100% of the material going into that bottle is gotten from plant based waste materials as well as recycled PET material from earlier bottles. That's a really impressive thing that they have gone ahead and achieved. And them being one of the largest companies on the planet in terms of consumption, it's a huge addition in the battle for a sustainable living. Moving forward to our second example, we talk about the country of Sweden. Sweden has a waste incineration program. 99% of Sweden's waste is incinerated. 99%. Only 1% of it ends up in landfills where it is further picked apart and disposed of either by recycling or by upcycling or refurbishment. The same incineration that is used to burn this waste provides heating for 9 lakh homes in Sweden and power for 2.5 lakh homes. A lot of you will suddenly think, oh, we have a lot of waste piles in India. Why don't we burn them? Yes, we can go ahead and burn them, but our government does not want to do anything about it. Hence, we have a mountain of waste growing all outside our cities. The Swedish waste incineration practice was so successful that it imported 13 lakh tons of waste from Norway, Denmark, and other European Union countries to burn since 2015, which means Sweden in the past 5 years has burned 65 lakh tons of waste of other countries in its waste incineration program. For more case studies on sustainable development practices in a variety of topics, I invite you all to visit this link for colby.edu where they have case studies which will be shared to you after the session is over. Dr. Thakre?
Okay, my mic was muted. Okay.
Go ahead.
Actually, in line with my next question, a very similar question has also been asked by one of our participants, Vivek Pandey, sir. First, let me read his question that India is a developing country, and during developing phase, environmental solutions are generally kept aside. So please throw some light on this. And my question was that what exactly is the ground reality or overall thinking process of the Indian industrial environment when it comes to sustainability, when it comes to sustainability projects and its practical implementation? How motivated or how positive are they to undertake such projects?
So I would like to go forward with Mr. Pandey, right?
Yes, Mr. Pandey.
Mr. Pandey's question, and I would like to say that India being a developing country, a lot of it is taken as an excuse for us to openly pollute. If if you all are aware, India has refused to sign the Paris Agreement for climate change under the guise that, oh, the developed countries did it all this while and grew. Why don't we get our chance to grow with a little less liability for pollution? What we don't realize is the rate at which we are damaging the environment in India. We will not even reach the developed phase of the developed countries without destroying our entire environment first. So, if you could repeat part two of that question, or if you could just type it in the chat so I could go forward with answering it.
Uh, yes, sir. That's the question. That what exactly is the real mindset, ground reality in the industrial environment in India?
Okay, so a lot of you are aware that we have the state and central pollution control boards in India. In Maharashtra, we have the MPCB and we have the central pollution control boards. The implementation of rules laid down by these boards is questionable. They have a long guidebook, they have a long handbook about what are the rules for different kinds of industries. But I don't think anyone implements these rules very effectively. The reason being, the inspectors with these rules are not qualified. There is a lot of red tapeism and there is a lot of bribery involved. And all of this has arisen from selective targeting of certain industries. The best example were cement concrete plants. A lot of you will realize that outside of Mumbai, we have the two cities or the two towns of Mira Bhainder. And when there was a construction boom both in Bombay and outside Bombay, there were at least 35 cement concrete plants that opened up in the twin cities of Mira Bhainder. All of a sudden, they realized that the government had given permission for these plants to open up. 3 years down the line, Maharashtra Pollution Control Board wakes up and goes down to all these plants and say, "Oh, you should shut down. You're causing pollution." Now, somebody needs to explain to me why was the permission given in the first place, knowing it is a cement concrete plant and it will produce dust, it will require stone quarry, it will require sand. You give the permission in the first place, and then 3 years down the line, when the plant may not be profitable yet, you go down to the plant and you want to shut it down. So, A, your inspectors don't know what they were signing on. And B, after 10 or 15 of these plants bribed a considerable sum together to the required authorities, these plants are up and operating again. So, during the approval process, if we do not get our foots down and say, this industry is being set up over here, it has to provide us with data that it is not breaking X amount of pollution norms, it is not breaking X amount of sustainable development as well. Going forward, a lot of people see sustainability as an additional cost and a cumbersome process to implement in their industrial processes. It leads to people having a careless attitude saying, "Oh, there's a lot of resources available. We shouldn't worry about it right now. We will produce. हम लोग देख लेंगे in the future." Another factor that is involved is that the inputs for production are very cheap, whether it is in terms of resources, whether it's in terms of labor, whether it's in terms of electricity. So savings by adopting sustainable technologies will take a long time. For example, we have received at least 5 proposals to move our campus onto solar energy. All these proposals have been showing that move to we will be able to get a renewable energy powered campus in 5 years time, and we will get our money back in 5.5 or 6 years time. What nobody realizes is that the rules governing the different aspects around us are so complex. I could install an entire solar power plant on my campus roof tomorrow, but reverse metering, net metering, and the very fact that Maharashtra State Electricity Board charges me 50% of my connected load as a commitment charge, which means even if I leave all my fans and lights and machines off, I am still paying Maharashtra State Electricity Board 50% of my connected load every month. So if we have such restrictive practices, everyone is always going to question, should I go to a sustainability or do I just end up paying the same amount no matter what? So I feel the Indian industrial environment has to mature. I'm speaking especially from the small and medium scale industries. They need to look forward. They need to reach out. They need to take advice on how they can get more sustainable. And as for the large industry players, a lot of them have taken active efforts to reduce their ecological footprint, which I congratulate them for. But it's the smaller and medium players that really need to step up of the game. Else, the large players with their efficiency gains will wipe out the smaller ones in the market.
Okay. Now let us open the platform for discussion and questions by audience. Actually, we have our one more question from the audience themselves. Mr. Raj Gupta sir is asking that do you think that future planning for sustainable development should be included as a subject so that it can help in the development of the country?
It's an excellent question, and it's a better idea that, as I said, design thinking, critical thinking is something that is required. And involving this as a subject, future planning, including sustainable development, will at least help the students to shift their thought process from regular ideas to maybe innovative ideas. An idea that may sound crazy may just be the next sustainable hit idea that we need. I would like to bring forward another example. Um, in Mumbai, they were not issuing certificates for occupation of buildings in case you did not have a renewable energy, in case you didn't have solar energy involved in the building. What a lot of buildings did is they installed a single solar water heater, even on a 25-story building, and they got the OC passed. So, no matter, even if we want to teach kids or we want to teach the students that look, you have to think from a sustainable point of view, we have to be very careful with the loopholes that our laws have.
Okay. Uh, one interesting question from Vivek Pandey sir. It is very much relevant to current time of COVID-19 crisis. How can industry maintain sustainability during this time of crisis? That's the question from his side.
Another great question, I would say. Um, One thing that people might have noticed is that a lot of positives have happened in terms of climate change during COVID 19 because most people have stopped traveling, industrial production has dropped, but people are only buying the essentials. Now, I know a lot of people will say, oh, look at my industry this, look at my industry that. But if somebody needs to explain to me that how the world is still functioning with the essentials being produced and the essentials being consumed, so it means that there's a lot of excess in our system. There's a lot of unwanted things in our system, things that may not actually impact human life directly, but they're just there because it's a competitive nature of industry or it's a competitive nature between two countries, whatever the reason may be. As of now, with factories being probably run at 33% or only 50% staffing, energy consumption of all these places has dropped significantly. And now would be a very good time for a lot of companies, if the right people are available, to do an energy audit of their company to understand where the power usage is going. Where are they, how much power is going at probably 50% capacity, and how much power is going at 100% capacity. Most of them may realize that the difference between operating at 50% and 100% is actually only 20% in terms of energy inputs. So my suggestion is right now is a very good time to cut cost And in case you're looking at cutting costs by not firing your workforce, it could be cutting costs by implementing sustainable measures. It could be probably giving better controls for your lighting systems, even motion sensors with your lighting systems. It could be getting a better design for cooling to enter your building. It could be more sunlight into your building. That's something that an expert can advise you on once they have a look at your industry.
Okay. Then we have one very interesting question from Mr. Rishikesh Mahimkar. As it is quite clear that automation is necessary for sustainable development, for a country like India with huge population, how to strike a balance between employment and sustainability? I
So,
think it is very much relevant with the last part of your last answer, I think.
yeah, it's how do we strike balance? How do we make sure people get employed? We already know that India has a huge number of unemployed youth, and these are a lot of these unemployed youth are also qualified by giving their graduate examination. What I would like to point out is most of the major large companies are going to be fully automated today or tomorrow. The only way to ensure, and them being private companies, they have no obligation to hire X number of people or work with X number of people. For
Okay.
example, yeah, for example, take the example of the German automobile manufacturers in India. You're looking at Mercedes, you're looking at BMW, you're looking at Volkswagen, Audi. Their plant lines are highly automated. Now, they are not under any obligation to employ 10,000 people. Yet, you will realize they employ people at points where human intervention is critical. It could be, for example, product design is something that a computer cannot do yet. A marketing survey is something that a computer cannot do yet. Salesmanship is something that a computer cannot do. Quality control, quality analysis, design for manufacturing, maintenance of machines is something that computers cannot do yet. They can diagnose what's wrong with the machine, but they cannot repair themselves. So, my advice or the idea that we should be working towards is how do we get ourselves into skill sets that require employment? I know that product designers are required. How do I go towards product design? I know that quality control is required. How do I become a QC engineer? I know that machine repairers are required. How do I get into that field? Where do I get this expertise from? If we do not adapt ourselves to get skill sets, then it's sorry to say, but automation will knock off most of the jobs, and only those who go and learn more will adapt and will survive.
Okay. So, sir, almost all the questions from participants have been answered. We have taken care of it. So, just if there is anything else from your side, you can please tell the audience, or I think there are no more questions from the audience.
I would really like to say that as a young generation of India goes forward, progresses, we have to be very careful about what we do to the environment. We have to be very careful about how we are using, reusing, and um, doing our bit to reduce our ecological footprint in the environment. If we take steps to reduce our environmental impact, it's ultimately better for us and our immediate future generations. And it's important to always ask a few questions before you do something. Why am I doing this? What is the purpose of this happening? Is this going to benefit only me or is it going to benefit the people around me? These are some critical questions that should come into your thought process before you start doing anything.
Yes, actually, this thought can be carried forward because 900 plus students have registered for this internship program, and it is, I think, the right time for them to start thinking in this direction. Yes.
Absolutely, sir.
Yes. Okay, sir. So, on this note, I express my sincere gratitude for you taking time out of your busy schedule and giving time to all our participants to discuss such an important aspect, which is generally neglected while going through regular manufacturing and other commitments related to the industry. And what you are proposing is a development continued, or what we can say ensured for a longer run, instead of only focusing on the profits for the shorter run. So that will be a thought worth giving time for the next generation as well. Thank you very much, sir.
Thank you, Dr. Hitesh, for having me on this internship webinar. I hope I have done
Yes.
my bit by contributing whatever I could, and I hope the rest of the webinar continues successful.
Yes, sir. Yes, fantastic.
Thank you very
Thank you
much.
very much, sir, for your time. Actually, audiences are also appreciating that the session is very nice and it has been helpful for them to understand this diverse topic of sustainability.
Yes,
Okay.
so if any audience ever has a question, if any industry has a question regarding sustainability, they can get in touch with you and you could forward their queries. We could sit across the table and discuss this, even if in terms of consultancy, in terms of practices, what they could require.
Hmm. Yes, for sure we can do that. Yes. Okay, so
And
thanks
sir,
to participants as
yes,
well for attending this session. Tomorrow's session we will be having on product lifecycle management, rather application of softwares and its effect on product lifecycle management as well as productivity improvement through that PLM analysis. It will be headed by a resource person from Center for Excellence in Maritime and Shipbuilding, which is a Government of India enterprise in association with Siemens. Yesterday, my sincere apologies. Yesterday, I announced that the session was planned for today. No, it is planned for tomorrow itself, Thursday. So that's a mistake on my side. So tomorrow there will be session on product lifecycle management and its role. It's a critical role in productivity improvement. Okay, thank you everyone for your attention. So I'm officially calling off this session right now. Uh, we'll meet tomorrow at 2 p.m. only, and a link of YouTube session will be sent in the Telegram group. Thank you everyone. Have a good day.